Why doesn't the earth seem to move when we jump? So the solution of this or the explanation will be very simple. From the Newton's law of universal gravitation, we all know this. From the Newton's law of universal gravitation, we knew that the gravitational force between two objects is mutual. So from the Newton's law of universal gravitational, we know that gravitational force between two objects is mutual, and we also know this equation, and the equation very simple. The law of gravitational equation, F equals g m1 m2 by r square, where so this is equation 1, where g is the universal gravity constant and r is the distance between the two objects. The distance between the two objects. Therefore, let this be the object of mass 1. Let it be of mass 1, and let this circle be the earth, and let its mass be m2. So this arrow and this arrow indicates the force between the two objects, and this is equal. And the forces, let it be capital F. But the question arises, why doesn't the earth seem to move? So the answer will be, we also know this equation, as we know the equation F equals ma, where F is the force and m is mass and a is acceleration, and from there we can derive it to a equals F by m. So there we can also tell this as a is inversely proportional to m. Very simple, a is inversely proportional to m, means more the acceleration less the mass, more the mass less the acceleration. That's why we accelerate. So simple, when we jump, we accelerate towards the ground. We accelerate towards the ground when we jump, because our mass is very less compared to the earth's. We have a very less mass compared to the earth's mass, and but the earth's mass is very much from our mass. That's why the earth do accelerate. The earth do accelerate. It is surprising, but it do accelerate, but we can't see it, as it has a very very heavy mass. And as we know, more the mass less the acceleration. So the earth's mass is more, that's why the acceleration is less. So thank you for watching. Thank you.